Section 3.1, fractions to decimals. Just a quick review of fractions and decimals. Fractions and decimals are both parts of a whole number, but they are not a whole number themselves. While sometimes there will be a whole number attached to a decimal or a fraction, they are not a whole number themselves. Any number without a decimal or a fraction is a whole number, but if it has a fraction or a decimal attached to it, it shows that there isn't a whole number there. There's a portion of a number being included. For instance, over here, our decimal places, tenths, hundredths, thousandths, 10,000ths, hundredths, thousandths, millionths. It is important to put the THS at the end because 10, 100,000, 10,000, 100,000, million are all numbers to the left of the decimal. When you add the THS, it's showing that it is a portion of a number. A tenth means it's been cut into 10 pieces. Hundredth means it's been cut into 100 pieces, and so on. A millionth means it's cut into 1,000,000 pieces. All part of a whole. To go, obviously, these two are in the wrong spot, but 4 over 10 is set as 4 tenths, so the 4 would go in the tenths area. 4 over 100 is 4 hundredths, and as you can see here, the 4 is in the corresponding hundredths. 4 over 1,000 is 4 thousandths, so the 4 is in the thousandths category. 75 over 100 would be 75 hundredths, and because that's ending in the hundredths column, it would be 75 hundredths. The 5 has to end in the hundredths column. Two types of decimals that we're going to be looking at specifically are repeating and terminating decimals. A repeating decimal is a number that continues on and on and on and on and on in a specific pattern. For instance, 0.3333333 continuing can be written one of two ways. It could be written 0.33 repeating or 33 hundredths repeating, or it could be just written down as 3 tenths repeating because technically it's a 3 that's repeating. The next number, 0.45454545, carrying on and on. The 4 and the 5 are repeating, so they would both be written, and this little line gets put over top of the numbers that are repeating. So it would be 45 hundredths repeating. The next number, 0.42156, 42156. The 42156 are repeating, so that would be written down 0.42156 into the hundred thousandths column, tens, hundredths, thousandths, 10,000ths, 100,000ths column, and a line is drawn over the repeating piece. And then there are terminating decimals. And a terminating decimal is any decimal that has a finite end, or it does come to a conclusion. So 531 thousandths. There are no other numbers after that. It does not continue. There is no repetition in those numbers. So it's 0.531, and that would be the end of it. This next number is a bit longer, 0.215674132. That goes into the the 100 millionths or the billionths category. There are no numbers that repeat. It does come to an end. It terminates at the end. It doesn't have a repeated pattern. So that would be called a terminating decimal. And then same with the last one. It's even longer, 7654, 7632. The 76 repeat, but there are no other numbers that repeat, and it's not considered in a pattern. And the number does come to a complete end. So that would also be a terminating decimal as well. Repeating numbers continue on and repeat in a specific pattern. Terminating numbers come to an end and do not contain any specific pattern. Another thing to look at in terms of fractions to decimals, if you look at 1 over 2, we know that that's a half, and a half can be written in decimal form as 0.5. That's something that if you've gotten received a quiz back or anything that has a mark on it, a half mark is often indicated with a 0.5. 3 over 10, again, the 3 over 10, the tenths, 3 tenths, it would be written as 0.3 with the 3 in the tenths column. 35 over 100, 35 hundredths, again, would not be written as 3.5. Would not be written as 35 thousandths. Because it's 35 hundredths, it needs to end in the hundredths category. So it has to end in that second column, tenths, hundredths, 35 over 100. So 3.5 is 3 wholes with a half. That doesn't work. This is 35 thousandths, ending in the thousandths category. Whereas this one here, 35 hundredths, 35 over 100, 35 hundredths. It's very important on which column the number ends in. Now, going from a fraction to a decimal, often people can make it out to be very difficult. Often the way that I find it to do is if you divide the top by the bottom, so 12, the numerator is the top, 12 divided by the bottom, or the denominator, which is 15, 12 divided by 15 will automatically give you a decimal, and in this case it's 8 tenths, 0.8. A way to look at that so it's a little bit more technical is you need to find a common number that will go into both your numerator and your denominator to get it into a lower term so that you can put it into some more, maybe a tenth or a hundredths, and easier numbers to use. Well, 3 goes into 12 and to 15, so if we divide both of those by 3, that gives us 4 over 5. But then we want to get to a number that's a little bit easier to use, and tens tends to be a little bit easier to use. So to get from 5 to 10, I need to multiply by 2, and that gives me 8 over 10. 12 divided by 3 is 4. 15 divided by 3 is 5. Multiply both of those, I get 8 over 10, or 8 tenths. While the answer is the same, the process was a little different. In this case, I took 12 fifteenths. I broke it down into a smaller number, and then put the denominator into tenths, which is a little bit easier to make into a decimal, or you can just go the numerator divided by the denominator, and you will get that number. 12 divided by 15 equals 8. The top divided by the bottom will give you a decimal. Of course, I could have done it the other way and made it 12 decimal 0000 and put it in and said, okay, well 15 goes into 0, nope. 15 goes into 12, nope. 15 goes into 120, and the 15 goes into 120 X amount of times. It goes in 8 times, and 8 times 15 is, in fact, 120. And of course, if I did my math and I did my proper long division, I would find that it's fairly straightforward. 15 does not go into 1, 15 does not go into 12, but 15 does go into 120 8 times. I have no remainders, 8 tenths, which is the same answer as I got back over here. Another thing that we want to look at is patterning. You'll notice patterns as you're doing math. A couple of ones that we want to look for and look at specifically are having 11 as your denominator and having 9 as your denominator. First things first, 2 over 11. If you divide 2 by 11 on a calculator, you'll get 0.18181818, or 18 hundredths repeating. If you do the same thing over here, and you'll do 3 over 11. If you do 3 divided by 11, you'll get 0.2727272727, or 27 hundredths repeating. And if you do 4 over 11, or 4 divided by 11, you'll find that you get decimal 3636363636, which of course again is 36 hundredths repeating. And you'll notice the pattern that comes out here. It's basically 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. Putting into the hundredths column, that means that 5 over 11 would be 0.45 repeating. Over to the nines, if I put 3 over 9, 3 divided by 9 is decimal 33333, or 3 tenths repeating. If I go 4 over 9, so I say 4 divided by 9 to find a decimal, it's 4 decimal 4444444, or 4 tenths repeating. So you'll notice that whatever number I put over 3 will give me that number repeating over here. It gets a little different when I use a double-digit number or a 2-digit number, so I moved up to 12. In order to make 12 repeat, I had to put it over 2 nines. If there are 2 digits in my numerator, I need 2 nines on the bottom. And you'll notice that 12 divided by 99 is decimal 121212121, or 12 hundredths repeating. If I have a single digit number, I put it over 1 9 to make it repeat. If I have a double digit number, I put it over 2 nines to repeat. If I had a 3 digit number, I would put it over 3 nines to make it repeat. Just a little pattern to think about and remember. So what you're going to do today for your practice is you're going to change these two fractions into decimals. 12/99ths, I want you to change into a decimal, and 8 thirds, I want you to change into a decimal.